Welcome to ECE 761 Robotics. This is a review of Matlab. Now, Matlab is a language that we'll be using extensively in 761 Robotics. This is just kind of a review to remind you some ways to use Matlab. The main thing in Matlab is it's a matrix language. You can write scripts, which is sections of code that you want to run over and over again, and functions, subroutines you can call. We'll be using those to run a robot, having it move around, as well as given the joint angles with the robot position. When you start Matlab, you get the console like this. So this is what the console looks like. Over here, these are all the subroutines that are in my current directory, the Matlab directory. Here is all the variables I have. Here's my command history. Excuse me. And pretty much I don't care. So oftentimes what I do is close that down, close this down, close that down, and I just have the big command window. Now Matlab is like a calculator. I can do things like what is 3 plus 4 and get 7. I can do more complex functions like cosine. I can also assign variables. I can say a equals 3, b equals 4. We're going to make the font size bigger so you can see it. File, Preferences, Fonts. And let's make these 24 points so you can see them. So I can now do like C is A plus B. It's a calculator. It is actually a matrix language. If I want to do a matrix, A equals square bracket 1, 2, 3, square bracket. The square bracket is the start and end of the matrix. Comma means next row. If I do a semicolon, A equals 1, 2, 3, semicolon, 4, 5, 6. Semicolon's next row, comma is next column. If I have a matrix, I can add them. So like if B is 2, 2, 3, next row, 7, 5, 2. I can say, what is A plus B? And it'll add those matrices. If I do a B transpose, that's the transpose of B. With matrices, you cannot multiply matrices that have incompatible dimensions. The inner dimension has to match up. So I can't do A times B, but I could do A times B transpose, or A times A transpose. In addition, Matlab will do complex numbers. And you can now do cosine of a complex number. Matlab's also kind of fun. It has nice graphics. For example, if you want to do a sine function, let's have t go from 0, steps of 0.01 to 10. Y is 2 times sine of t, plot of ty. You come up with a plot eventually. There it is. So it's a calculator that has graphics. A really nice thing about Matlab is with the internet, you can collect data. For example, let's go, here's a different class, 111 under resources. It's got things like the temperature in Fargo. So let's look at the monthly high in Fargo. Here's a bunch of data. I don't really want to copy that by hand, but what I can do is go into Matlab. Here's a copy, Control C. Now we'll go into Matlab and say my data is start of matrix, paste, end of matrix, voila, the data is in Matlab. If I want to look at the third column, January, February, that'd be February. That'd be all rows, third column. I can plot that data. So this is the high for the month of February since 1942. So Matlab has nice graphics. The biggest thing, which is related to the homework, is you can also do scripts. There's a script and a function. If I go under File, New, I have Script and Function. A script is a section of code that I want to run over and over again. A function is like a subroutine. To illustrate that, let's do a new script. And there it is over here. This is a blank script. If I want to do something like, let's generate a couple random numbers. So there's my routine. I'm going to run over and over again. Over here, I can now run that script. And it's going to ask me to save it. Untitled is a nice name. Run that script, and it just generated 5 random numbers, a 1 by 5 matrix of random numbers. Every time I run it, it runs that script. To illustrate what you can do with scripts, going back to Bison Academy, 761. Here's kind of a cute thing, a bouncing ball. This is a script doing some simulation of a ball bouncing in a box. The acceleration due to gravity is 9.8 meters per second in the minus y direction. If I integrate acceleration, I get velocity. Integrate velocity, I get position. In addition, this is a box. If I hit the right-hand wall, I'll bounce left. If I hit the left wall, I'll bounce right. If I go below -1, I reflect, bounce up. And then I'm going to draw it and keep on repeating. If I copy that, go back into Matlab, and paste, I can now run this program. And the important part of the program is at the end. The X limb, Y limb sets the scaling for the graphics. And pause pauses the simulation, lets you see it, and let it run. So if I run that program, let's bring up the graphics window over here. Run the script. This is the bouncing ball. And it's really slow while I'm recording. Yeah, here it is, finally got it working. This is simulating a bouncing ball. When it hits the left-hand wall, it'll bounce right. That's this code right here. When it hits -1, it bounces up. It reflects upwards. That's a script. If I want to modify it, it's fairly easy modifying the script. So let's go into the command window, hit Control-C, stop the program. Now let's do something like, instead of going straight up, I'm going to lose 10% of the energy when it bounces. I'll save that, rerun it, and bring back the window. Now when it hits the bottom, I'll lose 10% of the energy. So it goes up and bounces. That's kind of the first problem on the homework. Just running a script, modifying it to see what happens. In addition, there's subroutines. If I go into the shoot game, this is a subroutine that simulates a tennis ball being shot out of a cannon. If I now create a new function and replace it with that, the important part of the function is the keyword function. That tells MATLAB this is a subroutine. The name of the subroutine is called shoot. I'm going to shoot a tennis ball at a certain angle, like 25 degrees. Initial speed, like 10 meters per second. My target's out somewhere at 90 meters, wherever I want. It's going to launch the tennis ball, and when it hits the ground, it'll tell me how much I've missed by. So let's save that as the subroutine shoot. And I can now call it. So I'm going to get this over so you can see this and see the graphics window. If I say shoot, shoot is not a standard MATLAB name. It now exists because I saved it as an M file in the default directory. I'll say let's shoot at 45 degrees, 10 meters per second, and my target's at 90 meters. That will launch a tennis ball, and that's where it hit. So let's try at 20 meters per second. Let's try at 40 meters per second. That's a subroutine. I now have a new function called shoot that any other program can also use. That's the power of MATLAB. I can write scripts, sections of code I want to run over and over again. I can write subroutines, different routines that I want to create. The goal in the first week is just kind of get used to MATLAB. We'll be using it throughout the semester. This is just kind of illustrating some of the things you can do. The coming weeks, we'll be using MATLAB to simulate and animate a robot. And last thing to mention, there are tons and tons of commands in MATLAB. They keep on updating it every year. These are just some of them. You can do square root analysis, exponentials, do polynomials, trig functions, probability and statistics, display data, generally useful commands. That's just a small taste of it. MATLAB probably has thousands, if not tens of thousands of commands. It's been used for over 30, 40 years. Very useful program that we'll be using in this class. You'll probably use it in industry as well. So that's kind of a background on MATLAB.